Okay, I want to have a look at the chain rule way that we can do the integrals of these trig functions. So if we've got something a little bit more complicated now, not just a linear function in there. So have a look at these rules here. If you've got sine of f of x, then the derivative is f dash x times cos f of x. So this first bit here is something you did when we've just been doing the derivatives of trig functions. So working backwards, if you start with this, the integral is this, right? So if we have functions that are in this form here, I know straight away that the integral is just going to be sine f of x. Okay, working backwards, the fundamental theorem of calculus here. And that's what this step here. If we have something in this form, f dash x cos f of x, then the integral is just sine f of x. So we can force functions to be in that form there, like we see. So you might have cos of x squared with a 2x at the front. I know straight away that the answer is sine of x squared. And that makes life a lot easier. The second one, very similar, f dash x times sine f of x. It's just going to be negative cos f of x because the integral of sine is negative cos. Okay, now using this idea, we can now do integrals like this. Now I would look at this, and this is kind of an intelligent guess one. I know some of you don't like that, but this is what it is. Cos to the 4x sine of x. We're looking for functions that are in the form where we have derivative and then sine or cos. In this case, we'll say cos of f of x, like that. And we know what the answer to that is. That's going to be sine of f of x. But we also can deal with these like the reverse chain rule that we did before. So remember where we had something like this, the integral of f dash x, and then we had f of x to the power of n. Okay, remember that one there? So we know that the answer to this is going to be f of x to the power of n plus 1 over n plus 1 plus c. Okay, so let me give you an example. If we had something like x squared e to the x cubed dx. Alright, what we want this to look like for this to work is we want this to be like this. E to the x cubed dx. Okay, so this rule up here is for polynomials. This one here I'm now doing an exponential function. So, it's nearly right if we add times by a third in there. Now this and this are exactly the same, aren't they? I've forced it into that form. We've got derivative and then the function. And so I know the answer is just going to be a third e to the x cubed in here. If you do the derivative of that, you'll see you'll get it right. For polynomials, it might look something like this. The integral of x, and we've got in the brackets x squared plus 1 to the power of 4 dx. So there's a bit of revision here. So really what I want that to look like is this. 1 to the power of 4. Okay, you're with me? So I do that so that now those two things are exactly the same, and I've forced it into that format of derivative and original. And now I can say that it's this, using the rule for integrating polynomial functions. And of course we need half at the front there, so it would be x squared plus 1 to the 5 over 10 plus c. Okay, can you see that works now? If you do the derivative of that function, it will work. We're doing something very similar with these trig functions here. We've got cos to the 4x times sine of x. So I'm going to guess that the integral cos to the 4x sine of x, we've almost kind of got it in that form that we want. So you've got sine of x at the front here, and think of it like this, cos of x to the power of 4. Okay, the derivative of cos of x is sine of x. So this is exactly like that last one, exactly set up as I want it. So I've got derivative and then the original function to the power of something. So I'm going to guess that my answer is cos of x to the power of 5 divided by 5. And let's see if that's right. Let's see if that's right. If we do the derivative of this, we get 5 cos x to the power of 4 divided by 5 times the derivative of cos x, which is sine of x. These cancel, and that's exactly right. So that is the answer to that derivative there, using this kind of the reverse chain rule again. Okay, let's do b. So b is the integral of 3 sine cubed 4x cos 4x. All right. So hopefully you can get the idea that I'm kind of going to guess this is that it's going to be something like sine to the 4x to the 4 over 4, because the derivative of sine 4x is negative 4 times cos 4x. So we're just out by a certain amount there, aren't we? So let's guess that the answer is sine to the 4x over 4. So we've added 1 to the power, we divided by the new number. Now, how much are we out by there? Let's have a look. So let's differentiate that function and see how far we're out, because I think we're just going to need to add a number on the start and we'll have this right. So the derivative of sine to the 4x, let's write it like this, sine 4x to the power of 4. Let's do the derivative of this function. So we'll have 4 sine of 4x cubed, leave the 4 on the bottom line there, and then we need to multiply by the derivative of the inner function there, which is sine 4x. So the derivative of sine 4x is 4 cos 4x, correct? Right, so that's going to cancel with that. And what are we left with? We're left with 4 sine cubed 4x cos 4x. All right, now is that what our original question was? No, there was a 3 there. You can see the sine cubed 4x and cos 4x is exactly what we've got. Remember this thing in green here, I'm highlighting, should be the same as this thing here if we've done it right. If this is the correct answer, when we differentiate that answer, we should get the original problem back. In this case, it's not quite right, is it? We're out by a factor of, that one's 3, that one's 4. So what do we have to times 4 by to get 3? Well, we've got to times it by 3 over 4, don't we? That's what we need to do. So what I'm going to do is times this by 3 over 4. So our answer was right, we got the right terms, but it was out by a factor of, a little bit tricky there. Sometimes, that's 4 and that's 2, so we know, we just got to times by 2. Here we'd have to times this by 3 over 4, so the 4's would cancel, and you'd be left with 3 there. Okay. So my final answer then, just tidying up the numbers, you've got 3 over 16 sine to the 4x plus c. That's using the kind of reverse chain rule there to work out the integral of that trig function.